So here we are in the weld shop of the Harrier. This is where the Omega Arc platform or architecture comes to life, or where it comes together. And taking me for a quick tour is Mr. Mohan Savarkar, Tata Motors Vice President for its product line. Mohan, thanks for showing us around.
My pleasure.
We've obviously come to the end where a lot of it has been welded, but I think what we get a sense is there's some very complex joints over here.
Yes.
Getting those shut lines right. To be honest, I think that it can be sometimes a challenge. Pratap gives some fantastic shapes. I'm sure makes the job a little difficult for you all.
Yes, sure.
But I just want to understand, when you let's say the welding part, getting the finishes, getting the quality, what are various steps in that process?
So once we start with the architecture and the design that Pratap has brought in for us, so we have to make sure that we are able to split the design into doable parts.
Yeah.
And then the BIW, what you see here is where all these body in white parts are put together to make a total BIW.
Right.
Which makes a lot of influence on how the car will come out finally. So this is a very important part of the whole car making part here.
Right. Okay. And let's say these interesting shut lines, if I can point these out, and over here, you've got, let's say, this part is movable, this part is fixed.
Right.
Does this cause a bit of a challenge, especially when you've got a tailgate to get it to line up?
So what you see here is a number of parts that come together.
Yeah.
And it is important for us to make sure that the relative gaps between all these structures come out fine when the car is finally built. So what you see here is still very many parts are not here on the car.
Right.
So we have to simulate what is going to happen on the car right here in the BIW to make sure that all the parts come out very well here.
Right. And to be honest, I think there has been constant improvement. We did find a few gaps with the earlier cars, but is that a question of constantly calibration of the tools, getting the accuracies more and more fine-tuned to get to this point?
Yeah. So in any car, a constant journey for improvement is always on. You would want yourself to improve on very many parameters, and which is also to get the car build quality more and more refined. And this is something that we have always done in our weld shop, and you'll see that this is part of our life here. So with every car that we make, we collect a lot of data, and this data is used by us to make sure that the build keeps on improving. And as we keep going forward, you'll see that this process will continue in the future also.
You said it happens in the weld shop. Let's go to the weld shop, because I think that's really where it's all put together.
Sure.
Let's go. Come on, sealant, quite important, because this is what gives the extra rigidity as well as good for NVH. I mean, welding is one thing. Does sealant sort of complement the welding, or fills the gaps where the welds don't go?
Yeah. So it has the station that we are in right now is a sealant station, and what would happen here is that when you start spot welding around this, so there will still be some spaces in between.
Exactly.
So the job of the sealant is to make sure that the two sheet metals come together very nicely. So this will help us in, first of all, making sure that the joints are watertight. So in case of rain not coming in, for example, or wind not going in, for example, or dust not going in, for example, are things that the sealant will achieve. There are, of course, many types of sealants that we use on the shop floor, and some of them are also adhesive, strength-giving sealants that we use here. So all these different types of sealants are used on the line to make sure that, in addition to the weld spots, we are making sure that the body is extremely soundproof, dustproof, and waterproof.
Yeah, right.
And of course rigid.
Yeah. So benefits are basically refinement and durability.
Right.
Right. Okay. Great. So now I think next step probably, let's go to where the welds are done, because I think that is also quite critical.
Yes, please. Let's go to the next step.
Got a nice first floor view.
Yes, yes.
Yeah.
So from here you can see the whole line and how it goes forward there.
Great. So this is where all the welding is done.
Yes, yes. So what you're seeing here down below us is something called the framing station. And this is where the floor, the body sides and the roof, they all come together as one unit for the first time during the build of a car.
And this is all robotic. There's no manual. This is mainly automated.
Yeah. So the way that we have chosen our manufacturing processes is to make sure that we get the best dimensional accuracy and consistency across all the body in whites that we make here. And to do that, we have chosen robotics as the way to go. And most of the spots that we do on this line are today robotic in nature.
Right.
And not only the spots, but also the way we move material, the way we move the body is, as you are seeing here, is quite robotic in nature.
Okay. You know, you had told us in the presentation that Land Rover had a lot of input here, and that you know the people on the who developed the line were here for almost a year. So, how did that work in terms of the coordination, cooperation between JLR and Tata Motors for this platform? I mean, it is a Land Rover platform after all.
So the way that we went about that was, so we brought the best experts that Land Rover had at that point of time, who worked with us to make sure that the manufacturing processes are identical to the one that are there in Europe. And by that, we made sure that all the steps that need to be taken to produce an excellent body are in place, even in this location for us.
So, what is common exactly? I mean, there are some common parts. Is the front common? Is the firewall common? I mean, what's really common? Because obviously it's a completely different product. You've got your own unique twist beam rear axle. You've got a different engine, hydraulic steering, with the EPS. So just wanted to understand what's really the core common components.
So the way that we have gone about this is to make sure that the architecture hard points are carried over as is. So by that, what we mean is, let's say the suspension mounting point, or the steering point, or the distance between the two wheels, or the wheel track. So they are exactly the same as what a D8 platform has. So this is what ensures that the body rigidity as well as the dynamics of the car are very, very close to what you would find on the D8 architecture.
Right. Even the wheel track is the same.
Wheel track is
In
the
fact,
same.
even there was talk that you could have a Discovery Sport wheels slap onto this
Yes,
car.
yes. So the alloy wheels that we have chosen for this car at the beginning were the alloy wheels from JLR.
Right. Okay. So that's great. So clearly, I think this is a very crucial area where minimal human intervention and automation to get the right level of accuracy.
That's right.
Super. Let's go to the next step.
point. Sure.
Which one is it?
We will go to the place where we do the holes that are meant for the suspension.
Ah, that's right. Okay, that's the last bit.
That's the last
on
one.
the weld. On the weld.
That's right. Yeah.
Nice to see ladies on the shop floor. Yeah.
Very nice to see you here.
Yeah, nice to see you. So, I mean, it's you typically think this is a man's job, but clearly it's a job for everyone.
And we have had people like her working for us for recent past now. And this is something that you will see that Tata Motors is going to do more and more. And you will see more women folk on our shop floors.
That's really good to see.
Thank
Yeah. Hope you're enjoying it. So we are now going to the
Sunroof welding
Okay.
station.
Yeah. It's crazy how important sunroofs have become in India.
Yeah. So surprisingly for us, sunroofs these days are around 60-65% of our total volumes.
Did you hear that? 65% of Harrier volumes are the
Sunroof
sunroof.
today.
No wonder. But why did it take so long? I mean, a bit late. Did you feel that maybe you got a little caught out? Should have been there prepared a bit earlier, that the craze for sunroofs was much faster than anticipated? Or was it that in the manufacturing process it was just doing things a step at a time?
No. The way that we started off with this was there was always a belief that India being such a sunny and hot country, sunroof is not something that Indian customers will need.
Right.
But we have seen that trend changing quite a bit over the last 2 years. And once we saw that trend catching on, so we didn't want to miss the boat.
Right.
So even though Harrier had already been launched by then, so we went ahead and made sure that we could put a sunroof in place on Harrier.
Right.
And we could then time it along with the BS6.
Right.
And at that point of time, we could bring in the sunroof and the BS6 together.
So now that I've got you here, manufacturing of a sunroof, you cut a hole in the roof, torsional rigidity goes, stiffness goes. How do you compensate for that? Or does even the glass act as a kind of a bonded element to some extent and give you the required stiffness and strength?
Maybe there is something to a catch that we need to explain to you here. one would always think that a glass would tend to reduce the rigidity of the structure, but it's actually not so. The glass is as good or even better than sheet metal when it comes to rigidity.
Right.
In addition to that, as you can see on the welding fixture here, the sunroof cutout is backed up by a huge structure that goes inside it.
For extra reinforcement.
That is meant as to provide the reinforcement to reduce, to compensate for the reduction in torsion strength, and also to hold the sunroof in place and the sunroof mechanism in place. So this whole thing put together actually does not reduce rigidity at all. In fact, to some degree, it improves the torsion stiffness.
But the weight has gone up. How much should the weight go up by typically in a sunroof? About 20-30 kilos?
No, so it depends on the kind of sunroof that you put in the car. So our experience with this has been in the range of 12 to 15 kilos.
That's it.
That's it.
Only thing is in the worst possible place, which is right on top.
In a way, it is most away from the center of gravity.
Correct. That's what I meant.
Yeah. But all said and done, the car has been made in such a way that it is robust enough to be able to provide for this extra sunroof.
And that's what the customer wants. Customers want sunroof, so I guess you've got to give it to them.
Yes.
We are at the final station on the Weld line right now.
Right.
And this is where the suspension mounting points are Weld. Okay. So what's the advantage of that?
Yeah. So the way that we have planned the line is that all over the BIW shop, as welding keeps on happening, so there is a likelihood of all the tolerances getting stacked up, and because of which it is important to make sure that the most important points in the car are made in situ here on the line after measuring the car and making sure that the points are made exactly in the position that you want. So this is done by a piercing machine that you see to my left here, and when the next body comes here, you'll see that the piercing machine will come forward and make the holes after having measured the body.
Right. So what you're saying is that from the suspension point of view, to get the absolute accurate geometry, even from a tire wear point of view, I guess this is very critical.
Yeah. So the way that we have gone for in this car is we don't have adjustable suspension. So the adjusting has to be done only here, only in the BIW shop.
Right.
So in the final assembly shop, you just assemble the wheels and leave it.
Yeah, it's come
so
over
what you
here.
see here is the next operation is going to take place.
So this is where the last final operation is.
Right. So the green cylinders that you see here coming forward
are
going to do the punching job.
I see. Okay. Right. Got it. So this is probably the most accurate part.
This is the most important part that needs to happen in the car.
Because it affects the dynamics of the car.
Right. The loud noise that you heard just now is the punching actually happening.
Right. Oh, okay, great. Because I'll be honest, tire wear has been traditionally an issue with Tata Motors in the older days. I'm sure that kind of has reset or had a strong focus on getting these basics completely right.
So as our car making keeps on evolving, these are things that one has to take care of for the next model.
I remember the Indica initially, there were some issues there. Sumo also, there were some issues. I'm talking about 10-15 years ago.
It was quite in the past.
Come a long way from there.
We have come a long way from there.
Absolutely. Really good to see that, this sort of level of detail and process being followed. Again, was this, I guess this is probably a standard process now in the industry and something you've even got from Land Rover.
Not many people do it yet.
Right.
But this is something we felt was the right way of doing things for this kind of car with the kind of capabilities that one expects from a SUV like this.
Right. Great. Super. So if tire wear is minimal, we know this is the reason for it. Thanks.
Thank you.
So that's a quick brief tour of where the Harrier is kind of welded together. We've not seen the entire building process. We've just seen what we call the body in white, which really is the most crucial part. And that is the secret sauce. That is where the common bits of the D8 platform of Land Rover is being used. And clearly the Harrier has been a success. There are still a few gaps, Mr. Savarkar, in terms of petrol engines, in terms of different body styles, some gaps to be filled. But of course, it's an ongoing process. I think the result and the success has been amazing. As I mentioned earlier, numbers have jumped 4 times. It's a huge success. The flagship of the Tata Motors model range, the Harrier. That's what we've come to tell you about. Thanks for watching.